Yo, what's up, everyone? This is LeetCode 5, longest palindromic substring. Um, and we are going to do this in C++. We've done this in Python already, okay? So, right, there's really two things we need to understand. What is a substring and what is a palindrome, right? A substring is really just a contiguous, non-empty sequence of characters within a string, and then a palindrome is a basically a string or substring that reads the same forward and backwards, right? So we've done a problem in Grind 75 already where we have to basically check if something's a palindrome already. I think in that problem, the entire string, we were checking the entire string. In this problem, we're basically doing the same, but obviously the issue is it's not necessarily the entire string that could be a palindrome. The longest palindrome could be a substring. Like in this case, BAB is the longest palindrome, as well as ABA also is a valid answer. Okay, example 2, right? BB is the longest palindromic substring that exists in this string. Okay, so there's a bunch of solutions to this problem, some more inefficient than others. We're going to talk about the inefficient approach, right? Which is the brute force, which is basically like if we have something like ABAB or ABBAD, right? We could check, okay, check this substring, then check the substring AB, then the substring ABB, then the substring ABBA, then ABBAD, right? So finding all the substrings is n squared. And then remember, we have to check if it's a palindrome. That's a linear operation. So in totality, we have something that is n cubed for a brute force approach if we check it that way. Right, now this is generally inefficient, obviously. Anytime you have an n cubed solution, you know you messed up, unless you're doing some crazy hard problem in which maybe it would make sense, but generally speaking, you should consider whether you messed up if you have an n cubed solution, because that is pretty large, right? So that's not a good time complexity. So we're going to use a time complexity or a solution that the time complexity is actually n squared, and the space is O of 1. This problem has a DP solution as well, but I believe that DP solution is not O of 1 space, so it's actually even less efficient than the one I'm going to show you. So, but you can solve this with DP as well. But the way I'm going to show you, it's kind of intuitive in a way. It's not too complicated once I show you. But I will note something, which is that there is an obscure algorithm. I believe you pronounce it Manischer's algorithm, and that is linear time complexity, I believe. But it's an obscure algorithm for this type of problem. I really am not going to show you it because I don't think it's worth learning these type of obscure algorithms. I mean, you can look it up to understand it if you want, but I mean, like, I feel like in interviews, you're not going to remember these types of obscure algorithms, and you might mess up. You might forget, you might mess up. Like, I don't think they're worth learning personally. You have so many topics to cover when you're studying for interviews that spending your time, like, drilling, like, obscure algorithms, I think is just a waste of your time. If you have an interview that expects you to solve this, I mean, I think they're just kind of well, I'm not going to say any curse words, but I think they're just a mean person. So I wouldn't worry too much about it. I've heard like a lot of really good, really good smart people say the same thing. It's not worth learning these things. Like I've heard a Googler say the same thing, right? Someone who works at Google say the same thing. It's not really worth spending the energy drilling this topic, right? You want to focus on breadth. So just focus on understanding how to solve these problems efficiently, but without getting too bogged down by like obscure algorithms if it's a harder problem like this, right? So I'm just going to show you the O of n squared solution, which should be intuitive, and I feel like most interviews would accept it anyways. Okay, so first of all, how do we check if a string is a palindrome, right? We have two options, right? So we can expand from the outside towards the center, right? So we could have a left pointer at the start or right pointer at the end here, and then we compare those characters and then move the left pointer towards the center, the right pointer towards the center, do the comparison again, and keep doing that to get till we get to the center, right? If we don't run into any issues, any mismatches, right? Then we know we have a palindrome, right? Additionally, we could start at the center and expand outwards. So the left pointers and the right pointer start at the same place, and they expand here, right? The right pointer goes here. Okay, those match. Left pointer goes here. Right pointer goes here, right? We could start at the center, expand outwards. Now, with that expansion, when we're going outwards, from the center outwards, we also want to consider cases where we have a palindrome that's an even number of characters, like ABBA. What do we do then? Well, what we would do is we'd set the left pointer here, and the right pointer would be at the right here, right? So now we can do the comparison, right? Boom. And why do we have to do this? Because if we're expanding outwards, right, and we start here and we expand outwards, okay, we're gonna go out of bounds, right? That's not good, right? We're gonna start here, we're gonna expand outwards. Okay, this doesn't work. We're gonna start here, expand outwards. We get this, right? But we'll never hit this substring ABBA unless we when we're at a particular like index, we set the left pointer there and the right pointer at +1, wherever of I +1, wherever I is, right? So we need to basically handle cases where our palindrome is even length, so that is an edge case we have to handle because we don't know obviously if our palindrome is going to be even or odd length, so we need to keep that in mind. Okay. So we're gonna start from the center and expand outwards in terms of finding our palindrome. The reason we're gonna do that is because it'll be efficient because we're basically checking for palindromes as we go through the string. Like we're just gonna do a linear scan of the string, and as we're at every time we're at a moving forward in the character, we're gonna start at that character and expand outwards, and that way we can basically check all substrings without getting too bogged down by finding all possible substrings and doing it like in a very inefficient solution, because again we're basically expanding outwards as we go along, and so it'll make it slightly more efficient. Okay, so in essence, right, in case you're confused, what we're doing for our algorithm is we're basically going to have a for loop, and we're going to go through this string character by character. At every character, we're basically going to expand outwards from whatever character we're at, right? And if the left pointer goes out of bounds, the right pointer goes out of bounds, that would terminate our while loop, and we'd keep moving forward in the for loop, right? Because there's a while loop in the for loop, and the while loop in the for loop is what does the expansion. But if the while loop terminates, then we keep going forward in the for loop, obviously. Yeah, and we basically keep doing the expansion as we move along, character by character. Okay, so we're gonna expand outwards from whatever character they're at. Okay, I hope that makes sense. If it doesn't, okay, it'll make sense as I write this code, right? So we're gonna say longest length palindrome, right? We're gonna have a start. Okay, so remember what I said. We're gonna have a for loop, and we're gonna iterate through the input string. Okay, so we're gonna say for int I or equal to 0. Sorry, I haven't written C++ in quite a bit, so bear with me here. Okay, so for int I is less than 0, what is our input string s? So I is less than s dot size, right? I plus plus. Okay, now we're iterating through this input string character by character, right? So when we're at a specific character, right, that's going to be what? The index I, right? So remember, for odd length palindromes, the left pointer and the right pointer start at the same place, right? So we're going to say int L is equal to I, R is equal to I as well, right? The pointers are at the center, okay? And this is where our while loop happens, right? So basically, while the left pointer is in bounds and the right pointer is also in bounds, and whoops, and basically the left pointer and the right pointer match, then we know we so far have a palindrome. Now this will initially always be true because again, the left and the right pointer start at the same place, or when we start a check, right? When we're at a specific, let me just write something like this, right? When we start at this A, the left pointer and the right pointer are initially both pointing A. So of course, at least initially, we'll always enter this while loop. Okay. So if we do, we need to basically check that this window we have so far, of this palindrome, basically how long this palindrome is. If this is longer than the than the longest length palindrome we have seen so far, then that means we need to update our starting place and this. Okay. Now, if you're curious why I'm doing this, right, why I'm storing it in these variables, like start, why do I even have start? Is because, right, let's say I have something like this, okay? This is initially this is the longest palindrome, okay? So we have A, right? Then we find ABA, right? I'm not going to continually take like a substring and store it in a string here, because let's say we have a really, really long string and we keep finding longer and longer palindromes, and then a longer palindrome, and then a longer palindrome. If we continually do string splicing in here, it makes our algorithm less efficient, right? So this is a slight optimization where I'm basically just finding the starting spot and I'm storing that in a variable, the index, and then the longest palindrome, basically the size of the window. So that way, at the end of our program, we know our longest palindrome is we're gonna have the starting place, and we're gonna have how long the window is. So we'll take the substring from whatever this index is, and then we'll go this far out to find our substring, and that's how we'll retrieve our longest palindromic substring. Because if we continually do string splicing to find the substring here, we start to run into, I mean, I don't think it'll break this program. I think I've done it before, and I think it's okay. But it's just inefficient. And again, like in interviews, you want to use everything. You want to optimize as much as you can. Especially in a, I mean, you never know, man. Like that little things like that can be the difference between you passing versus another candidate passing, right? Like just slight little optimizations like that show the interview that you know what you're doing, right? And that you're actually thinking about stuff thoroughly. Right, so that's the point of this, okay, or why we have a start variable. Okay, so here we're going to move the left pointer to the left, the right pointer to the right, obviously, because we're going to keep expanding our window. Okay, so that should be it for that. Now down here we're going to do even length palindromes. Okay, so we're going to do L is equal to I, and R is equal to I plus 1, right? Because remember, right, I'll go through it again. If we have something like this, if the left and the right pointer start at the same place, we'll never go hit a case where we cover these four, right? This palindrome, right? Because if we start here and we expand outwards, we start here and we expand outwards, we start here and we expand outwards, right? Like we'll never hit these four. The only time we'll hit these four characters is if the left pointer starts here in this case, and the right pointer starts here. Okay, let's compare them. Okay, they match. Nice. Expand outwards. The left pointer goes here, right pointer goes here. Oh, now we check this substring. Okay, so this is a case where we have an even length palindrome, and this is why where we set our pointers matters. Okay. Okay. So yeah, basically the pointers are next to each other, right? I'll just comment a little bit. This is the same code though. Like we're doing the expansion exactly the same. So in fact, I'm just going to copy this. Boom. Okay. Should be okay. Boom. Now, this is the, let me just comment here just so it's easier to read, because I know I always put my braces on their own line, but I know it can be a little bit confusing to know what is matching to what. This is the end of the for loop, right? This is the end of the while loop. Okay. So now down here, we need to return basically the longest palindrome so far. So, the way we're going to do this is we're going to do return s dot substring start longest bound, just like this. Because if we have something like ABBA, right, the start would be, when we hit this 4, right, the start would be set to 0. The longest length palindrome, obviously, is R minus L plus 1. So this would be 0, 1, 2, 3. 3 minus 0 plus 1 is 4. It'd be 4. So we would go from, basically we would do s dot substring 0, 4. But much like Python, right? Much like string splicing in Python, when we take a substring, and I know I have said string splicing. I know technically I don't think you call it that in C++. You call it substring, right? But you get the point. Like, we're just taking a substring. I say substring and string splicing, but they're interchangeable, right? At least for my purposes of this video. But much like Python, right? To take a string splice, right, using substring here, this function, it's inclusive, right? It's inclusive, exclusive, right? What does that mean? We're basically taking the substring from index 0 up to, but not including, index 4. So in reality, we're going from 0 to index 3, right? So index 0, index 1, index 2, index 3, right? So remember, this is not inclusive. This is inclusive. This here is exclusive. This here is inclusive, right? I just want to make sure you understand that, because I don't want you to get thrown off by what these two variables are basically doing. So yeah, that's basically how we store and then use it later to calculate our longest palindromic substring. Okay, I know it's a little funky kind of doing it like this, but I mean, I just want you to understand. I just want you to understand that I'm doing it this way so we can so we don't continually do this string splicing continuously in here as we find longer and longer palindromes, because that is going to be inefficient. Okay, so yeah, I think that should work. Boom. Now, because we're writing the same code here and the same code here, we might want to use a function, right? Especially in an interview, it's kind of good to optimize, or not optimize, but just write clean code. I mean, it goes a long way, right? You don't want your interviewer to be getting lost, right? So we're gonna just write a helper function to expand around the center. Okay, so we're gonna say void expand on string s, say int l star, boom. I'm gonna say, put this in here, right? And then down here we can just say odd length palindromes, right? So we're gonna say expand, and we're gonna do s I, and then even length, right? We're gonna expand s, left pointer at I, right pointer at, remember, not at I, but I plus 1. And assuming I didn't do a silly little error, this should be okay. Function definition not allowed here. I have to put it outside this yet. So what we're going to do is we're going to take this, I'm going to put it up here. Boom. My bad. I forgot I am supposed to obviously put it outside this function. So this here, we're going to put this. Let's see if I remember how to backspace. I think it's Control Shift Tab. Oh, no. Control Shift Tab? No, not that. It's Shift Tab? Oh yeah, it's Shift Tab. My bad. I forgot. Okay, there you go. Sorry. Forgot it's obviously a function. It can't be in here. But assuming I didn't do anything silly, again, should be okay. So yeah, this is this solution. Okay. Yep. This video is already a little bit long, but I'll just run through this code, right, just so you're not confused. I always do this at the end of my videos. Makes my videos a little bit long. I'm sorry, but if you care to stick around, if you're still confused, I'll just go through this. So obviously this is what gets called. So we'll talk about that later. We'll just start at the beginning of the program, which is right here. Right, this for loop, we're really just using this for loop to iterate through this input string character by character, right? When we're at a specific character, like we start here, right, we're going to basically call the expand function. And from here, we're going to set the pointers both at B, right? And we're going to expand outwards by the left pointer going to the left, the right pointer going to the right. And we're going to see if we have a palindrome, right? And the way we check that is by basically do this here, right? Does the left pointer and the right pointer equal to each other? And are they in bounds? Now, of course, we could have even length palindromes. So we also want to check the case where we set the left pointer at I and the right pointer at I+1. So technically, we're also checking this here if it's a palindrome, right? We're doing both. Okay. I mean, that's basically the program. I mean, right? And this is maybe the only thing I can think of that you might be confused on. But remember, we're just doing the string splicing. We're storing when we find a palindrome, we're storing the starting place and how long the palindrome is, how long the window is. And we're using that down here to do the string splicing or finding the particular substring from the starting index to the ending, but to the ending index. Remember, inclusive, exclusive. And we do that for efficiency's sake, because technically you could basically do something like, okay, the longest palindrome string we've seen so far, right? And we could basically do the substring stuff in here. But if we're continuously doing substring stuff like string splicing, if we find longer and longer palindromes, because we could have a really big input, like our input string could be super long, so we could keep finding longer and longer palindromes over and over again. Oh, we just found another longer palindrome. Oh, another palindrome that's even longer. Another palindromic substring that's even longer, right? And if we're continually doing the string splicing, right, it starts to get a little. It won't break the program, I believe, because our input size isn't crazy, but it will be inefficient. And let's say you have an interviewer who gives you crazy big input sizes, then he might start nudging you towards something like this, where he wants you to not do the string splicing in here, but to do it down here, right? By basically just storing the variable, the starting place, and the window size. Okay, I hope that makes sense. I tried to explain that as best I can, but you can ask questions if you have any. Yeah, and I hope this helped, and I will see you in the next one. Peace out.